ॐ भूर्भुवस्सुवः तत्सवितुर्वरेण्यं भर्गो देवस्य धीमहि धियो यो नः प्रचोदयात्. Hello friends, welcome to my channel. Today we are going to discuss about diode and its characteristics in detail, which is a part of analog electronics for electrical students or electronic devices and circuit theory for electronic engineering students. Before going into diodes, it is very important to know about the basics of diodes. For any subject, basics plays a strong role. Hence, the basics of diodes will come your semiconductor theory, which we will discuss today. In semiconductor theory, it starts with the classification of materials. Materials are classified into conductors, semiconductors, and insulators. This classification may be done based on their conductivity, or based on their band energy, or based on the number of valence electrons in an atom. We will see one by one. First of all, let us give me some examples for conductor, semiconductor and insulator. Conductors are metals. Semiconductors will be your 4th A group elements like silicon and germanium, and insulators will be 8th A group elements. Now let us see classification based on their conductivity. You can see here when the conductivity sigma taken on the y-axis, the things which has high conductivity is your conductors, that is graphite, silver, copper, almost metals, that is 1A and 2A group elements almost. Whereas the conductivity, that is sigma, is in a 10 power minus series, that is very least, from 10 power minus 7 below, that is glass, Teflon, these are all your insulators. And the conductivity which is in moderate range, that is in between conductors and insulators, comes your semiconductors. Hence, based on the conductivity, we can classify materials as conductors, semiconductors and insulators. Now we will move on to another type of classification. Based on number of valence electrons present in atom. Conductors generally will have 1 or 2 valence electrons. Semiconductors will have partially filled outermost orbit, whereas insulators will have completely filled outermost orbit. Now we will see what is meant by energy band and its classification. When energy band is a band which is formed by energy possessed by various electrons. If these electrons are valence electrons, then the band is called valence band. If these electrons are free electrons, then the corresponding band is called conduction band. And forbidden band is the band which is in between valency band and conduction band. I will repeat it once again. Valency band is defined as energy possessed by the valence electrons, whereas conduction band is defined as energy possessed by free electrons. And forbidden band is a band which is present in between valency band and conduction band. Now we will see classification of materials based on the energy bands. See, based on energy bands, materials are again classified into conductors, semiconductors and insulators. In this diagram, the first diagram, which has a very large energy gap between valency band and conduction band, is insulators. That is, all electrons will be present in valence band and the conduction band will be almost empty. Why? Because the electrons in the valence band to jump or to transfer from valence band to conduction band is impossible. Why? Because the energy gap will be greater than 6 electron volts. The second case in the diagram, that is, the conduction band and valence band is overlapped. This is for conductors. For conductors, valence band and conduction band will overlap. Hence, easily conduction takes place. Hence, it will have more conductivity. When we see the last one, which has a moderate energy gap, it will require some temperature and some external factors for conduction. That is, if electrons transfer from valency band to conduction band. This third diagram represents the case for semiconductors. That is, some electrical field and some external agencies like temperature that are all required to push electrons from valency band to conduction band. Now we will see what is the classification of semiconductors. Semiconductors are classified into intrinsic semiconductors and extrinsic semiconductors, where extrinsic semiconductors are again classified into P-type extrinsic semiconductor and N-type extrinsic semiconductors. First of all, we will see what is meant by intrinsic semiconductors. Intrinsic semiconductors are pure form of semiconductors, where conduction is done by movement of electrons from valence band to conduction band at room temperature under the influence of electric field. Under the influence of electric field, this will happen. Then we will see some classification. Before going to extrinsic semiconductor, we should see some things like classification of charge carriers. Charge carriers means the particles or things like electrons which carries charge and produce some current are charge carriers. Classification of charge carriers. Charge carriers are classified into majority charge carriers and minority charge carriers. Majority charge carriers place, suppose in an atom or in a particle, suppose there will be many charge carriers, but based on the number of charge carriers, one will be in majority and some other will be in minority. Like, in the same way we can define this majority and minority charge carriers. Then we will see what is meant by a hole. Hole is an ideal concept. Hole is not present practically. When electron transfer from valency band to conduction band, the hole is assumed in the place of electron before moving to conduction band. For intrinsic semiconductor, both holes and electrons are equally generated. Why? Because when electron move from valency band to conduction band, the electron in the valency band when moved to conduction band, electron will be increased in conduction band and immediately hole will be created in the previous place, that is before transfer from valency band to conduction band at the original place of electron. So a hole, one hole and one electron is generated. Similarly, equal number of hole and electron pairs will be generated for intrinsic semiconductor. Now we will see how conduction is produced in intrinsic semiconductor. When electron moves from valency band to conduction band, produce electron current. Immediately, due to creation of hole and movement in reverse direction of electron, produces hole current. Total conduction of current is due to the sum of hole current and electron current. Now we will see extrinsic semiconductor. What is the need for extrinsic semiconductor? Due to poor conductivity or due to poor conduction of current with room temperature under the influence of electric field, we are going for extrinsic semiconductor. Here what we will do, to increase the conduction of current, we add certain amount of impurity called dopant to pure semiconductor. This process of adding impurity to pure semiconductor is called as doping. Based on the dopant added to extrinsic semiconductor, extrinsic semiconductors are again further classified into P-type and N-type. In P-type semiconductors, the dopant added will be a trivalent atom or 3A group element which has 3 valence electrons. And as we know that semiconductors are 4th group elements, it will have 4 valence electrons. During bonding, we will see. See here, boron is a 3A, 3rd group element which is a dopant which is added for increasing its conductivity. And germanium, silicon, these are all belongs to 4A group element, that is semiconductors. Now, if you observe, the three valence electrons of boron are bonded with 3 valence electrons of germanium, whereas the 4th valence electron of germanium, for bonding with the another germanium atom downside, there is no electron. The 2 dots here represent a hole. Notation is here 2 dots represent the hole. Boron is from 3A group element, so it will has 3 valence electrons. The upper three valence electrons are bonded with the 3 valence electrons of semiconductor, whereas for bonding with the another germanium atom, or we can say the 4th valence electron of the germanium atom is left without bonding. For bonding that, we want another electron. As there is no electron, we assume it as a hole. For bonding that we want another electron. So this is called as acceptor impurity. That is, it is ready to accept electron for bonding with the fourth valence electron of pure semiconductor, that is here germanium. This type of extrinsic semiconductor is called as p-type semiconductor. P-type semiconductors will have majority charge carriers as holes and minority charge carriers as electrons. Now we will see n-type semiconductor. In n-type semiconductor, dopant added is pentavalent atom or 50A group element which has 5 valence electrons. And we know semiconductors will have 4 valence electrons. During the bonding, 4 valence electrons of the dopant bond with 4 valence electrons of pure semiconductor, and 1 valence electron of dopant will be left. See here, Sb is antimony. Antimony is a 50A group element which has 5 valence electrons. The 4 valence electrons of Sb bond with 4 valence electrons of germanium. Another valence electron of doping, that is dopant, antimony, is left free. So here it is a free electron is there. By this we can say that majority charge carriers will be electrons and minority charge carriers will be holes. See, once again I will explain. I will compare both and I will explain. See here. Here boron is from third A group element and germanium is from fourth A group element. Boron has 3 valence electrons whereas germanium has 4 valence electrons. 3 valence electrons of boron bond with 4 valence electrons of germanium. And for bonding with the 4th valence electron of germanium, there is no electron from boron. So there we assume a hole. Hence, here hole is there extra. Hence, majority charge carriers will be holes and minority charge carriers will be electrons. See here. For p-type, majority charge carriers, holes will be assumed as positive and electrons we know already it is represented as negative. Similarly, for n-type semiconductor, 50A group elements will have 5 valence electrons and 40A group elements will have 4 valence electrons. Among 5 valence electrons, 4 valence electrons will be bonded with the 4th A group elements, that is with semiconductor, and 1 valence electron is left free. Hence, majority charge carriers will be electrons, that is negative symbol, and minority charge carriers will be holes, that is positive symbol. As an electron is present extra here, and it is ready to donate an electron as it don't want for bonding. These are called donor impurity. As an electron is lag or a hole is present in p-type, due to it is ready to accept an electron. So it is called as acceptor impurity. Thank you for watching my video. Do share, subscribe, comment and like. For further more videos, do subscribe my channel. Thank you. In my next video, we will see about diode, its characteristics and its applications. Okay friends, for more educational videos, do subscribe our channel, A.R. Educational channel. Share, like and comment friends. We need your support. We need your support which motivates us to do more videos further. For learning basic concepts and test your knowledge and to give suggestions and also to clear your conceptual doubts, follow us on our Instagram account. Thank you friends for watching our video.